Good evening. I am Rasika Gamage, Seminar Secretary, Sri Lanka Energy Managers Association. I warmly welcome all of you to the 50th Energy Management Forum of Sri Lanka Energy Managers Association. This is one of the series of events conducted by SLEMA in order to improve the members' knowledge on different aspects of energy management. With this one, we will be completing half a century of events forums since inception. Today, our topic is developing hydropower resources, future potentials and opportunities. Today, we have a very good presenter, one of my university colleagues, to deliver the presentation. Presentation will be 40 minutes, followed by 20 minutes Q&A session. You can raise any question or query through Q&A or chat platform, in the Zoom platform in order to take up during the Q&A session. Thank you very much to all of you. Then I will hand over the session to Mr. President, Mr. Tamila Jayasekara, for further proceedings. Thank you.
Thank you, Rasika. Good evening, everybody. As Rasika was mentioning, we are having the 50th Energy Management Forum conducted by Sri Lanka Energy Managers Association, SLEMA. Yeah, it is a very important milestone because it is basically a knowledge sharing event. So successful knowledge sharing event for the 50th time is a very good milestone. And it is a very coincidence that we are going to have a very iconic theme for the 50th Energy Management Forum. That is developing hydropower resources, future potentials and opportunities. By isolation, it is very iconic because we have been able to develop good high expertise in this field. I think in that sense, it is one of the most important areas of energy, not only in renewable energy only, but in the entire energy spectrum. Hydropower is a very important area for us, for the energy sector of Sri Lanka, because as we have developed expertise in the country, we have been able to go beyond the country in this subject. Our experts have tremendously contributed the development of micro hydropower in the regional countries as well as international level, and also have been able to provide expertise in the particular area. So today we have a very experienced person in the subject to share knowledge on the subject with us. He's Mr. Engineer Upendra Walpola, who graduated from University of Moratuwa in Electrical Engineering in 1997 and completed his Master of Engineering in the same university in 2006. He's a chartered engineer and a corporate member of the Institute of Engineers Sri Lanka. And he has been in the field of small hydropower development for the last 25 years, and has been involved in as an engineer, project manager, operation manager, and at such various levels, and has been involved with different stakeholders, and also has been involved in foreign factory acceptance test in the subject, etc. So I think he has ample knowledge and experience of the subject. So we are very fortunate to have him today as the resource person for discussing on this topic. So without taking much time, I am very happy to invite Mr. Upendra Walpola to have his presentation. Thank you very much.
Thank you. Good evening to you all. Thank you very much, Mr. Chamila and Mr. Asika, for introducing me, and I am very much honored and thankful to Sri Lanka Energy Managers Association for inviting me for this presentation on developing hydropower resources, future potentials and opportunities. Since this topic has various directions to proceed, I had to select a moderate approach as this is a public lecture, as well as participants might be from different professional backgrounds and maybe having different level of understanding on this sector. So considering all, let's move to the presentation. Can you see the slide now?
Yes. Okay. Go ahead.
Right. Okay. My presentation has 10 main topics, and I hope they will provide you some knowledge on the subject. First, I will give you an introduction to small hydropower, covering some basics. Thereafter, I will move to pre-construction activities from there to site selection and related studies. My fourth topic will be selection of electromechanical equipment for a particular site. Next, required approvals and clearances will be looked, and my sixth point will be commercial aspects of projects. To provide you some ideas on construction work and installation, I have included chapter 7, and evacuation of electrical power will be briefly discussed under chapter 8. My next topic will be operation and maintenance of small hydropower plants, and finally I will look into future potentials and opportunities. As I mentioned earlier also, I have summarized most of the details to cover the topic and include much as possible. Therefore, I appreciate your understanding to this approach followed in this presentation. As there is no widely accepted definition for small hydropower, I have chosen a typical classification, and in this presentation, I prefer term small hydropower for plants having installed capacities from 100 kilowatt to 10 megawatt range and grid connected. Despite store capacity or water head of small hydropower project, major components of them are almost similar. The figure I have chosen here shows them in graphical manner. Even for the other components not shown in this figure, like turbines, generators, electrical switchgear, synchronization, transformers, etc., are common to any grid-connected power plant. If we look into local scenario, small hydropower is one of the major renewable energy contributors in the Sri Lankan power generation sector. You can see the exponential growth of capacity additions to national grid from 1996 to 2001. And also I have extracted this graph from CB website, which shows national electricity generation on a day few days back. In this graph, it shows the contribution of small hydropower to the national grid. On this particular day, the share of small hydropower was 3.5 gigawatt hours, or 13.7% of total generation. However, I want to mention here, not all hydropower plants are counted here. Only the plants connected to the plants that provide details to the CB system control are counted for this web presentation. That compared to other renewable sources, small hydropower requires less land extent to generate same amount of energy, as well as it also create large number of employment opportunities than ground mounted solar and wind power projects in Sri Lanka. Before going into details of project development, I would like to summarize the pre-construction activities which are listed here. Of course, this is only a guideline and there may be some more steps in these two stages, that's pre-feasibility and feasibility stages. I have shown the approximate duration taken for each stage also. In this process shown here, I have not included the establishment or incorporation of project companies. because some developers initiate the project application by their personal capacity and incorporate the company at a later stage when the legal requirements arises, such as agreements to be signed and permits are to be obtained. Selection of a suitable site for small hydropower project is most important of all, and developers spend a long time to select a site which is taking into consideration several factors, as it is a vital decision of the whole process, and any error in making this selection would result in not only infeasible project, but project in terms of environmental and social terms, but also collapse of businesses and corporates of them too. Therefore, due consideration should be given to factors I have listed. Sometimes there are more than what I have mentioned to make the project feasible environmentally, socially, and economically. Here I would like to share some photos taken on field visits which show sections of upstream catchment areas and features of this catchment, so that any developer would consider them for a good hydropower catchment. This is a river profile of a upstream project. You can see there are tree plantation on one river bank, and river has a wide section. But this is a good sign for water retention. This is a good sign of water not retaining sufficient for hydropower generation, because of upstream less forest cover, as well as tea plantation makes a lot of evaporation of rainwater. This is also catchment area which mostly covered with tea plantations, and not very suitable for development of a hydropower project. This is a low-head project site in Ratnapura. It has a wide and large extent of catchment area. And the problem is, you can see the river flow is not clear. That means a lot of upstream activities are going on, like gem mining and cultivation without soil protection methods, so that a lot of debris and mud collected to the river, and it is also not very good for develop a hydropower site. This is fairly a good location for a diversion. We are in a river that is also located in Ratnapura district. This river has a catchment area mostly covered by forest and good for hydropower development. This is also predominantly tea plantation, and river flow may go dry as soon as rain stops, so that not very suitable for development of a project. If we further go into little bit into site selection studies, there are several studies and field measurement have to be carried out, and some of them are listed here. Topographical maps are a very basic and fundamental tool, and it's an essential source of information when doing a feasibility study of a hydropower project. Sri Lanka completely covered with 1 to 50,000 and 1 to 10,000 topographical maps, and latest editions of these maps are readily available with the survey department. So digitized maps are also available and useful when determining the catchment area. Rainfall and other river flow measurements are essential in hydrology study and would reveal the optimum river flow which can be diverted for power generation. A flow division curve for particular stream can be developed with hydrology study, and it is very essential information for plant designers to determine the suitable plant capacity. Head measurements and site surveys are performed by qualified surveyors with the help of modern surveying equipment and tools. Geological assessment is also vital since most of the hydropower development areas are prone to disasters like landslides and rock filing, which are required to be identified in advance and take measurements to rectify them. Out of all the project-related studies, environmental study is the complicated and most important study which is mandatory according to the environment law of the country. It is therefore usually undertaken by a team of experts from different specialized areas of study, and Central Environmental Authority is a leading agency in this process. Acquisition of land for small hydropower project needs several challenges, as well as the process is a little time-consuming task. Though it takes considerable time to discuss the land acquisition process, I should emphasize incompetence and handling and lack of support from prospective landowners would result in the delay in the project, as well as incurring heavy expenditure in payments for acquisitions. If I talk a little more about site selection and studies, these photos show a flow measurement technique using current meter. It is a part of determining river flow, widely used by hydrologists and project designers. As I mentioned earlier, topographical maps are basically used for finding the extent of catchment area, usually above the diversion point of or via point and other geographical features. EISO land use maps are also useful in examining the nature of catchment area, and this is a land use map of upper catchments of Kaluganga in Ratnapura district, where you can see about 40% of the catchment has forest cover, and it is a fairly good catchment, though rest of the area is comprised of mixed vegetation. This is a flow division curve derived from for a medium head site, and its catchment area is around 40 square kilometers. We can get an idea about the nature of catchment by analyzing the flow division curve. For example, in this flow division curve, you can see there's a river discharge about 2 cubic meters per second for 80% of the exceedance or 80% of the time. Whereas dye period will have a discharge of around 1 cubic meters per second. Therefore, we can assume the catchment area has a moderate water retention capability. Physical measurements of river profile is done along the water source. It is essential for finding out gross head of the project. Almost all the project developers get the services of project consultants specialized in different areas such as environment, construction, machinery, selection, etc. They have a big task of evaluating the measured data and outcome of the studies like hydrology study to carry out various design options of the project. It is a duty of the project developer and the investor to look into the different design options and select the most suitable option to proceed. Some of the results of studies carried out with regard to the project location and river flow can be summarized starting from determination of plant capacity, with the determination of plant capacity, other factors such as civil constructions, civil structures, and project plan stock designing, electromechanical design can be done. In addition to civil and electromechanical designing, project infrastructure planning and selection of equipment supplies and service providers are to be decided as an indirect result of project-related studies. Under this section, I have on calculation, I have briefly touched the basic calculation related to small hydropower, which is widely used by designers as the fundamental calculation of power output using the head and flow. Here I need to point out the importance of net head of a particular project, as it directly involves to the plant output as well as cost of the project. I will come back to the flow division curve again, as I need to show the importance of selecting the optimum design flow for a particular site, particular plant. Here I have taken an example by taking two values of exceedance, 40% and 80%, of the flow division curve, which related to two corresponding design flow values. It can be seen both values have merits and demerits. Therefore, it should be looked not only consultant but also by investors' point of view when determining the most suitable design flow. Once a potential site for the small hydropower plant is selected and gross head and optimum river discharge is determined, suitable hydro turbine for the plant can be selected. There are three major types of hydro turbines available, which are impulse turbine, reaction turbine, and gravity turbine. Their applicability for a particular site depends on the availability of water head and river flow. Suitability of a turbine for a particular site is illustrated in the turbine selection chart, and results can be approximately tabulated in this table. Out of different types of turbines, Pelton turbines are the choice of most developers for both high and medium head plants. Selection of generators is not complicated as turbine selection. However, their coupling method, generation voltage, excitation, runaway speed, etc. are the parameters important in selection of the generator. Unlike in earlier days, some generators are specially manufactured for hydropower application like this. They are to withstand high runaway speeds. Balance part of the electromechanical system comprises turbine governor, valves, power and control cabling, electrical switchgear, protection schemes and relays, step-up transformers and grid interconnection facilities, which require thorough planning and designing work of project consultants according to the guidelines published by CEB. Next, I will move to the somewhat time-consuming area, approvals and clearances pertaining to hydropower development. Sri Lanka Sustainable Energy Authority, or SLSEA, is a governing body for grid-connected small hydropower sector. An application for a new project has to be submitted to SEA with a pre-feasibility study report, and application process flow is shown here. After getting the provincial approval, a developer has to obtain several other approvals from line agencies as listed here. This process would take at least 1.5 years if the developer is lucky enough to get it done quickly. However, by getting these approvals will not be sufficient. actual implementation process is more complex, including areas like project funding, land acquisition, etc., which sometimes need certain approvals go forward and backward, and which are listed here in this diagram, which is somewhat complex. Then you can understand the process is not as simple as we think. Next, I will briefly look into commercial aspects of small hydropower projects. Almost all the projects commence with equity capital, mostly up to construction stages or even towards the middle of it. Since the power purchase agreement with CEB guarantees revenue for a quite long period of 20 years, and the tariff is known, cash flow analysis for a small hydropower project for a whole PPA term can be done with certain assumptions with large high level of accuracy. Here I have illustrated the basic steps in summary for the financing arrangements of a small hydropower project. For construction work and installation section, I don't intend to go into details, but rather give some examples and briefly discuss them. In any runoff river type small hydropower project, diversion weir across the water source is the first civil structure that we come across, which is followed by intake and headrace channel. Depending on the terrain, headrace channels are sometimes several kilometers long with additional structures like aqueducts, culverts, etc. Water diverted and conveyed via headrace channel, then directed to forebay or head tank. In some projects, forebay tank has been constructed at the intake of the river or the weir due to difficulties of the terrain for a headrace channel. Manual or motorized trash removal methods are installed in the forebay tank to remove debris from entering into the penstock pipes. Design and installation of penstock pipes require a lot of engineering expertise, since they are often on difficult terrains, and failures will lead to disasters like soil erosion, flooding, and landslides. Some developers prefer GRP for glass reinforced plastic pipes over steel pipes due to its bearable conditions like lightweight, low maintenance, and less friction loss. And they are, however, not very suitable for the areas like rock falling or any threats like falling trees, like that. Powerhouse and tail race have common features like powerhouses have common features like turbine flow, generator, and electrical switchgear, flow control room, etc. Yeah, constructions differ based on project type, that is whether project is high head, low head, or riverbed project. Riverbed projects are not available in Sri Lanka, but small hydropower house will be either one of the other two. Being a matured industry in Sri Lanka, large number of qualified and experienced engineers, technical staff now available for installation work of complex electromechanical equipment. Unlike in the past, foreign equipment suppliers now required to present only for testing and commissioning stages of the machinery, where local expertise can install almost any machinery according to manufacturer's instructions. Evacuation of electrical power is the outcome of the hydropower plant, and I have listed main equipment and important areas of concern. At the completion of everything, power plant is ready for testing and commissioning. Of course, testing on civil construction and penstock can be done during constructions and installation, but electromechanical testing needs diversion of water and running the plant. Testing on electrical panels and protection relays are done according to the specifications and requirements of CEB. Most of the small hydropower plants have in-house maintenance staff and own maintenance schedules. However, specialized tasks like machine overhaul may require additional external expertise. Most of the plant staff would be able to maintain stocks of some spare parts and service records of the machinery they have, which are essential for long period of operation without any trouble. As we discussed earlier also, small hydropower sector has a significant growth during last 27 years from the completion of grid-connected first grid-connected plant in 1996. Most of the years capacity addition in the grid were in the range 20 to 40 megawatt per annum. However, you understand not all available potential site can be utilized for hydropower generation. Nevertheless, it is believed further further exists sites with total extractable capacity in the range of 100 to 150 megawatt. This is in the basis of environmentally and socially feasible sites. I have listed some possible small hydropower generation locations which are currently not utilized much, and it will not require cooperation. It will require cooperation with institutions like Irrigation Department and Mahawali Authority in this task to accomplish. To local opportunities, there exists quite interesting opportunities in African region, which have already been ventured by some local developers. In addition to African region, Asian countries like Nepal, Vietnam, and Laos also have small hydropower sites to be developed, though less funding and other facilities available compared to African countries. Other than project implementation, it is encouraging that now we have local expertise for equipment supply for small hydropower projects. Of course, there are concerns for manufacturing complex machines like Francis and Kaplan turbines, but our local manufacturers have successfully produced Pelton turbines for both local and export markets. Not only turbines and turbines and other machinery, our expertise is there for design and manufacturing control systems, which are better than some other some foreign similar products. Some of locally manufactured turbine generators control systems are already running at both local and foreign projects. With this, I have reached the end of my presentation on hydropower development, future potentials and opportunities. And thank you for your participation and attention. We are now time for Q&A session. Thank you.
Thank you, Mr. Valpala, for the very good presentation.
Thank you.
Please use the chat box so you can. I think, Mr. Valpala, there are questions already in the chat box.
Okay.
There are six questions.
Yes.
Shall I read it for you?
Yeah, please go on.
Okay. First one, the question is from Mr. Chanakadi Silva.
Yes.
Okay, before that, are you in a position to switch on your camera?
Yeah, sure, no problem.
Because there was a question he was Mr. Priyadenag is asking to switch
yeah,
on the
okay,
camera
okay.
during the presentation. You may have not seen the message at that time. Anyway,
Yeah,
the
yeah.
questions number 1. What are the potential environmental impacts associated with future hydropower projects, and how can they be mitigated?
Yeah, actually, future small hydropower projects mainly will be low-head projects. Low-head projects will have different environmental impacts than medium or large head projects, high-head projects like flooding and riverbank erosion, like those. So, special attention has to be paid to these environmental damages as well as the other requirement much imposed by some other agencies like irrigation department or Mahali authority, because these low head projects are mainly sites are mainly owned by those two institutions. So that most of this time, this environmental impact assessment, these two institutions will be the project approving agency. So they will impose certain extra conditions in making the environment impacts lesser. So shall we move to the second question? How can we optimize the efficiency and reliability of future hydropower plant in the face of changing climate patterns? Actually, changing climate will result mainly the river flow. The river flows are mostly these low head projects are controlled flows. So that that means the site will be downstream of another reservoir or a tank. These reservoirs and tanks will collect water despite the climate, despite the rainy season, and they can be released mainly for irrigation purposes as well as other requirements like drinking purposes. So the efficiency and reliability of future hydropower plants in the sense of low head projects are not very much depend on climate changing because of this control upstream water resources. What innovative technologies or designs can
So Valpula,
yeah.
so I think there are questions coming in. Our host, Mr. Harsha, will be able to give the participants the opportunity to ask questions. I think
Okay.
can mute themselves. Isn't it, Mr. Harsha?
Yes, you can raise your hand so I can unmute the participants so they can ask questions. So just to get this rolling, let me ask you a question, Mr. Valpola. Now, we are seeing now Sri Lanka is a solar country. Everywhere you go, there is a massive solar resource right on your rooftop. And in that scenario, and with the reducing costs of solar equipment, do you still think we have to develop the remaining potential of the small hydro power in the country, or can we leave it as it is without disturbing the environment, let it be, and forget about small hydro and then move on to solar and wind? What do you think?
My personal opinion, Mr. Harsha, is 50-50. As you might remember that the area that we land extent, if we consider land extent, solar power would need large amount of lands than for same amount of power output than from a hydropower. In that sense, the land requirement will be a critical issue in Sri Lanka. You know, there are so many areas covered with different types of forests. So we might not have the required lands for large solar projects. and we might be looking for some other sectors like other options like floating solar or rooftop in large scale. In that case, I think we can still have potential sites for hydropower, not causing much environment or social impacts. And we have to forget certain sites. It's correct that we have to forget certain sites, and they incur a lot of investment than projects of medium or high-head sites, because we need to maintain environment regulations as well as other requirements imposed by some agencies. Therefore, it is 50-50. We have to forget some section of hydropower, and we have to look for solar. But the problem of finding lands for ground-mounted is there. So we have to think of other ways like floating solar or maybe rooftop. I'm not sure very sure how large projects can be developed, but we have to look for the practices of other countries, like building solar projects over the roads, main roads, like that. We have to look for innovative ways of developing solar, so that we can get rid of depending on land requirement, as well as we can forget some of the hydro projects that may be not economical or even environmental friendly.
Okay, thank you very much. And I forgot to congratulate you on the good presentation. One of the best presentations I have ever seen on this sector. So thank you very much. And we have Mr. Keshav Raj from, I think, from Nepal. Keshav, you can raise your question.
Thank you very much. Mike, as I am from Nepal, I'm currently in Thailand. This is like, I want to know which international agencies are like primarily funding the projects, the renewable projects across Asia.
Mr. Raj, I am not very clear your voice.
Can I repeat the question? He wanted to know which international agency is funding our renewable energy, rather small hydropower projects.
In Sri Lanka?
In Sri Lanka, yes.
And across Asia, like other countries as well.
At the moment, I don't think we have international agencies funding small hydropower projects in Sri Lanka.
Is it government, Sri Lankan government?
No, actually, this at the moment it is mainly developers' own funds or bank loans and all. No international fund is available for development of small hydropower at the moment.
Just to clarify, Mr. Valpola,
yes,
we started our small hydropower industry mainly with a credit line from the World Bank. Actually, two projects, Energy Services Delivery Project and the rural, Renewable Energy for Rural Economic Development. But after we finished those funds, the local banks started lending money to the developers because they were confident without donor money. Our industry became kind of self-sustained with local money. So that is the and presently, the largest active donor in our country is the Asian Development Bank, who recently funded a 100 megawatt wind power project in Mannar. So all the major donors are actively engaged in renewable energy financing. And thank you, Mr. Raj, for your question. And now we have Mr. Parakrama Jayasinghe raising his hand. Mr. Jayasinghe, you can ask your question. Unmute yourself and speak.
Yeah. Okay, good to hear you, Valpal, a long time.
Yes, Mr. Parakrama.
And a great presentation, all right.
Thank you very much.
I have put on the question and answer, two pertinent questions. The most important one is there's always such a objections and protest by the environmental groups against mini hydro.
Yes.
But I don't know whether how valid they are. But is there any way of sort of anticipating that kind of thing, and how can we mitigate them? And connected to that is also, I'm asking, maybe Harsha can answer that. What is the role of SEA after all, SCA provides the approval, preliminary approval for project. Now, is there a possibility of making sure that SCA looks at this problem right at the beginning without putting the developers in trouble later, to make sure that any objections are looked at right at the beginning? This is the most important thing we should be doing, because I still believe there's a lot more potential that we can develop, and we can't ignore that. So those are the two most important questions I want to raise.
Okay, Mr. Parakama. First, I will look into the first part of your two questions. This environment issues raised by NGOs. Actually, I look into this issue this same now. Certain projects, actually, we also admit that certain projects have caused certain environment problems. Actually, doing a project will not be 100% not making any damage to the environment. Project, when we are doing construction work, it will somehow make a disturbance to the environment. The thing is, after the project, developer should be able to recover that loss he has done to the environment when the project construction phase was going on. Now, I want to emphasize the thing now. A lot of projects now, we have industry more than 25 years old. Now we can look into the projects that developed 25 years back, how they have amalgamated with the environment. How these developers have make the environment back to the same stage where this developer, this project not constructed. Like that, we have to think of the constructive way, not just blaming or making trouble to each and every project. Of course, there are projects that are making impact to the environment, and still laws are there to handle that kind of actions. So making a complete or blanket allegation to the entire industry is not justifiable. That is my view on that, Mr. Parakam. I think Mr. Harsha can answer the second part of this question.
Actually, we undertook a two-step process just because of this problem. That is, the first approval, provisional approval is granted only after the related agencies are well consulted by the project developer and the SCA, whether it is in a doable location. But sometimes after giving the provisional approval, there can be situations where we discover more environmental issues than we anticipated in the very beginning. So then the agencies propose various mitigation actions, or sometimes we have to completely give up that project. That is the reality. But from the SCA side, we just like the client's lawyer, we always stand by the developer meeting these agencies. Mr. Valpola would agree with me. We go with the developer to Central Environmental Authority, Forest Department, Wildlife Department. Everywhere we have built very good, strong relationships, and we have even personal relationships cultured over 2 decades of our working with them. So it is not as bad as many people would report, but the environmental lobbying is not a Sri Lankan phenomenon. It is everywhere. If you take a country like the United States, you will be amazed to learn project gestation period there is about 7 years. So we managed to develop projects within about 2-3 years. So in their case, the lobbying is so severe, it takes more than 5 years for a renewable energy project to get off the ground, not to fully develop. So we are comparing apples with oranges there, but we are trying hard with our limited capacity and limited resources to help the industry as much as we can. Thank you.
Mr. Harshad, there are 2 questions. I am going to combine the 2 questions. One from Mr. Ravinath Rupasinghe and another one it's an anonymous attendee. I don't know what it is. Anyway, the questions are: what would be the cost per kilowatt for small or mini hydro? That is one question. The other is, what is the payback period of present small hydropower projects? Mr. Walpola, will you be able to answer those two?
Yeah, actually, this is a very somewhat difficult question with current financial terms. But anyway, it is about 300 Sri Lankan rupees per megawatt is a somewhat good rate of good per megawatt cost of a small hydropower project. And the payback period, actually, I have to
Sorry,
go back.
the answer 300, what 300,000, or it's not clear for me at least.
Actually, it's
300 million.
Sorry. Actually, I made a mistake. It's about 1 megawatt. It's around 500 million with
Sri Lankan rupees.
Sri Lankan rupees at the moment. And payback period is also not very attractive these days because we are not very sure about the rates of the banks and bank loan rates as well as other parameters. But for a small hydropower project to be feasible, it should be around 6 to 7 years.
Yeah, I think you answered both the questions. If they have any further clarifications, they may raise hand, and
Yes.
we'll be able to let them get it clarified.
Yeah.
Mr. Jaiswal, are there any more questions from you?
Yes, I posted another question. Actually, now the potential of our irrigation canals for mini hydro is much more. It might be pico even. You see, but then we have such a large number of canals.
Yeah.
And also, I must say that large number of reservoirs themselves. Now, the best examples are Uduvalave and Giniagala. We don't seem to be paying too much attention to those.
Yes.
Where these problems with the environmentalists may not be so rampant.
Yeah.
Is that area that maybe your association is looking at, or have anybody done any studies on that?
Association means
get connect a small power hydro.
Okay. Now, Mr. Parakam, actually, as an association, it has not looked into because maybe individual developers may have looked into the possibilities. At the moment, as far as I know, the framework for doing a project at these locations are a bit restricted. So first of all, we have to get the consent of these authorities who own the sites, or even maybe some regulations to be passed. Or we can make sure that they also get a benefit of that. Like that, without any of such initiative, developers have no way of looking into the possibility of harnessing the energy of those sites.
Yeah, I wonder whether Harsha can add anything to that.
Yes, you are battling the environmentalists when it is greenfield sites. You have to battle the farm organizations and related
Yes.
people.
Yeah,
when you are
true. That's all right.
Convincing farmers also a very difficult research.
Yeah. It is. I have faced a situation. Even the Agrarian Services Department, along with the Govisangvidana, it's virtually impossible to penetrate them, and they are not on our side. Very frankly.
Yes.
No, but I believe that is because of lack of knowledge.
Lack of knowledge, yes.
We are not taking their water away.
Yeah, and other thing, Mr. Parakma, I see this initiative from top is not there. No support from state agencies to get this into the farmer level. If a developer goes, he will be chased away.
Definitely. I think that's why again I'm saying that SEA has a role to play. Because for that one, you must at least, even before going and developing it, we must do an assessment. You see?
Yes, assessment. Yes, assessment should be done. Otherwise,
I'm sure it will turn out to be very, very appreciable.
Yes.
We have a fair idea about 100 megawatt of capacity left there in the irrigation, whatever, but
Yes.
all are developable. But it will take a long time. Actually, we started lobbying the irrigation department and them in 2008 and gave up after 5 years of struggle, to be very frank with you. So it's virtually, it's not possible to be very frank.
I appreciate your problem answer.
Yes.
But this still is an asset that we can't ignore.
Yes, yes, correct.
But there are peculiar problems, I must also admit. Doing a project on a irrigation canal is not a very easy as a greenfield site. So there are very serious complications, archaeological as well as structural engineering related issues. So we have to be quite cautious. So most of the projects we might have to face a lot of difficulties.
I raised this question, Harsha, because I have seen very good examples in India.
Yeah.
Yeah, correct. Lot of low head projects are done in India. Maybe riverbed plants like that. Maybe 5-6 megawatt, less than 10 megawatt. So many plants.
Yeah.
Oh, thank you, Mr. Singh. Mr. Harsha, will you be please allow Mr. Bhatia Pradeep to talk? I have a question to him. Until that, I will read out another question to Mr. Valpola. It's from Mr. Pradeep De Silva. Is there any possibility or any future plan for mini hydro pump storage system among existing projects? One of you.
I don't think mini hydro pump storage will be feasible because pump storage inherently large projects. You know, this amount that we invest for a pump storage will not make if it is feasible if it is a small project. So that mini hydro pump storage will have no possibility among existing projects.
Thank you. Bhatia, can you answer if I pose a question to you?
Yes, I think you can hear me.
Yeah. First of all, thank you, Bhatia. And Bhatia is one of our member, and he has engaged in small hydropower sector for some time, locally and in other countries. So, and since this webinar is partly and kind of a joint webinar with the renewable training hub for renewable energies in Sri Lanka, the Sri Lanka project, which is still implementing in basic developing stages. So I would like to ask from Bhatia, what are the opportunities you see outside Sri Lanka for young engineers, those who are entering this renewable energy sector? Both Mr. Pendra and Bhatia can answer my question. Bhatia, first you can give some inputs. What are the opportunities available for young engineers entering into this field?
Yes, actually, in my career, I was fortunate to work in multiple Sri Lankan projects at the early stage of my career with one of the Sri Lankan developers. And later, I mean, in last employment of myself, I was involved with multiple projects in African region, basically Uganda, Rwanda, and Zimbabwe. Actually, I think now Sri Lankan expertise are extended even to Zimbabwe because they also had better. Now they just started mini hydropower. Basically, they are having a lot of reservoirs, and during the construction of reservoirs by these European companies, the European designers, they have kept an outlet for development of hydropower projects. The project what I have involved in Zimbabwe, we just need to connect that outlet to our penstock pipe. That's it. Simple as that. Like that, I mean, Zimbabwe is one of emerging area, even though they are not doing well financially, but A lot of these European funding agencies are looking for Zimbabwe, as I know, because I have some contacts and with them, even though I'm currently not working in Zimbabwe on these projects, African projects. But the main thing, main advantage what we have, when I compare with those our competitors, basically, when I speak regarding the expertise, providing expertise or consultants for these projects, the cost, basically, one thing is the cost of consultant fee, and our expertise and experience of designing, optimizing the structure. Basically, that's what I mean, good thing what I understood when I was working in these projects. And there are few companies in Sri Lanka, design firms, which I used to work also, now extending their services towards these European funding agencies. Therefore, I believe those who are interested on these renewable energy or hydropower projects, there will be good opportunity. But only thing is getting into the market, because without having the previous experience or knowledge on them, generally they don't allow our companies to enter into their thing. That is there. I mean, that is one area I can say. We have a good potential, basically Uganda, Rwanda, and Zimbabwe, because I had first-hand experience with those projects, and other country. What I think is we have best opportunity in India. Basically, currently I am working in India for one of the European consultancy firm. Now, as per the India's current energy policy, they are trying to double the renewable energy generation capacity by 2030. Currently, the installed capacity is around 170 gigawatt, and as per their plan, by 2030, it will be increased to 400 gigawatt installed capacity. Therefore, now they are going in big way to develop PSP, basically from storage projects, where I am also involved in currently. Therefore, India, I think we have big potential for our engineers who have experience with hydropower. I mean, I know in Sri Lankan context we don't have experience in PSP, but even those who have experience in hydros, because all the concepts are same, there are technically there are few things to be understand compared to hydropower concepts and PSPs. Therefore, in India now, there's a big potential and big demand for engineers who are having hydropower, conventional hydro, PSP knowledge. I think
yeah, thank you, Bhatia. Mr. Valpola, do you have anything to add there?
Yeah, actually, I agree with Bhathia's explanation. And in addition to that, what he mentioned is important, because without experience, no foreign employment is easy. So, in the same time, young engineers with background on electronics and control systems will have opportunity in designing this control systems or SCADA or turbine controls, whatever, in these projects as an additional thing than civil or any mechanical engineers involved in these projects. So I see even these young engineers with electronics or electrical background should look into these areas in foreign projects, because most of these components they just get from foreign suppliers, maybe reputed brands or some reputed suppliers. But in the same time, we have experience, our engineers can do those better than them, and good troubleshooting also there. So opportunity exists for young engineers to learn these control systems and other electrical protection schemes will have a good opportunity in these projects.
Thank you. Actually, this Bhatia was mentioning about the African countries, but I know another young SLEMA member, the company in Europe, actually the Croatian company, and
Yes.
for the past few months he worked in Nepal, Vietnam, and I actually invited him to join this session, but he is traveling to Spain for another hydropower project. So there are so many opportunities around the world. If somebody,
Yes.
that's why I just wanted to highlight this point here. So
yeah, not only this Asian or African, even experienced or talented engineers will have opportunities in European or American projects also. I know an engineer who's working in a hydropower project in Canada. So the opportunities are there. Only thing is that we have to have your talent and eager to learn and do experiments and go ahead.
Yeah, the one thing I wanted to highlight is if you have the opportunity to get trained or get some experience in this sector, I think we should not hesitate, because there are people say that there's no opportunities in Sri Lanka for small hydro, but there are a huge world outside this.
Yes.
So that's what I wanted to highlight.
Dr. Amila Vikramasinghe has raised his hand.
Thank you, Mr. Harsha, and let me first congratulate Mr. Valpola for making an excellent presentation. Very nice. Thank you very much for that. And then secondly, talking about young engineers getting into the this mini hydro field. Back in 2001, I think there was no Sri Lanka project, no online platforms. It was Mr. Walpole. I don't know whether he remembers as a young undergraduate. He taught me all these, the how to calculate the catchment areas and all these. And after 22 years, I'm still learning from him. So thank you very much.
Thank you, Amile.
My question is actually those days you were involved not only with mini hydros but even village hydros, and time to time Mr. Harsha has discussed about this potential of reviving, or whether it is worthwhile to revive those small hydro projects, estate hydros and village hydros, which are, I think, mostly idling now because the grid has penetrated to these villages. What is your opinion, having first-hand experience? Do you think it is economically, worthwhile to, maybe repair them and, refurbish them and connect to the grid, or should we just let them, be abandoned?
Amila, now I think there was an initiative from SCA to get these all projects into the grid. It is true that most of the projects have been abandoned due to grid penetration, and there was an initiative. I don't know how successful it was, but the possibility is there. If the machinery is available, we have to do some modification for low voltage grid interconnection, and CEB also supportive in that manner. Like if solar can be connected, why we can't connect hydropower to the grid? So I look in that way. We can get a lot of state plants and small projects that are scattered over the villages to the grid. So the only thing is they are state now. We know about 15-20 years back, those were very much in good progress. And Ms. Arsha, we remember RERD project did a lot of these village hydro projects at that time. So I think if this plants are available and the machineries are in good condition, the possibility of connecting them to the grid should be looked into. I think most of these plants in the tea estates are in good condition because they are not just abandoned. They somehow keep them in good condition. Mr. Harsha, I think you can also add something to it.
I have a different opinion, sorry about it, because most of these village hydro equipment, at least not the estate hydro, village hydro equipment are not meant for heavy duty. I have to tell you, as one of the manufacturers of hydropower turbines, we used very cheap induction motors, and there are so many duty cycle issues associated with the mechanical part of the machine. So reviving those, in my eyes, there will be substantial cost involved in getting the right kind of M&E equipment into the civil structures are okay. They were very sturdily built, and we have no problem in using them. But I still don't think the mechanical and electrical part will be suitable for full-time duty cycles, Dr. Miller. Just one more question by Mr.
Arvind, no?
Hi, Mr. Valpola. Thank you very much for your very informative presentation. I have a
Thank you,
question
Arvind.
regarding the refurbishment of the small hydropower plants. Since most of the small hydropower plants are getting old and they may need some refurbishment works, but the renewing tariffs are very low and the employers are not in a position to initiate them because it is not much feasible.
Yes.
So in that way, we are losing energy due to the least efficiency machines. And what's your opinion about the tariffs renewal process? And is there any implementation methodology to consider these factors? Because already sites are allocated and we are running with less efficiency.
Yeah,
That's what I'm
actually,
wondering.
yeah. Now, for the time being, we don't see any progress of altering the existing agreements with CEB, and we have already requested CEB through the association. But since it's a legal document entered with both parties, and I don't think it is CEB is agreeable to change the terms in the near future. Of course, it's a problem. So problem with rates that entered about 10-15 years back are very much low compared to current terms. So it is very difficult thing to maintain the plan. So I think someone should look into government or any other agency should look into this problem, because by the time of end of power purchase agreement, these plant will be no more, because they can't maintain the plant towards the end of power purchase agreement. This cost of spare parts and consumables have gone very much, so it more than double. So it is very true what you are saying, but the problem is still there, but solution at the moment is not in reachable level.
Thank you very much, Mr. Valpola.
I would like to add something there. Actually, when we design the legal framework for these small power projects, we concentrated on small hydro, not other types of technology. So we had an intention of giving a further 20 years extension to energy permits, actually, 20-year energy permits, with the very serious idea of repowering these projects, meaning after the 20th year, we thought the developers will invest some money in the refurbishment of machinery and civil structures and give us more energy with the modern machinery and to have a new power purchase agreement from the 20th year onwards. But due to the chaotic situation in the sector, the government side and even the financial side, we just couldn't get it right. So we have to admit that. But repowering contracts is the future. We are looking not only at the hydropower, but if you take the wind turbines, you definitely can get better wind turbines in the 20th year for the same location, more energy from the same footprint. And the solar panels, no different. So you will have better solar panels, better inverters in 20 years from now. So we have to get ready for that eventuality. That is the way forward, I think. We have to work as a team to get the best for our country without fighting each other.
Mr. Harsha, is there any benefit to the existing developers that who are on agreement with CEB, maybe 10, 15 years old or like that?
Actually, in most of the developed countries, the repowering contracts are, there is a first choice, that is the previous developer is given the first chance to do the balance period, 20 years. But if he's negotiating a very high price, that particular site is open to new developers. So the original developer will have to compete with new developers to retain his title. So that way it becomes a competitive process. As you know, it is not the most, the industry doesn't like competition in our country. So that way we are still far behind the Nordic countries I'm referring to. So that is the way to keep the prices in a manageable place. So the repowering, if you there is an entire new industry, the repowering industry. So if you refer the dialogues in those forums, you will understand what I mean. So we have to get more solar, wind, and biomass, and also hydro for the 20th year and the eventual next energy permit. We have to work as a team and arrive at a good solution. That's my wish.
Okay.
Yeah. Yeah, Walpala, if no more questions, you'll move into the.
Sorry,
Mr.
there are two hands raised.
Mr.
One from Mr. Ravindranath Fernando, and Mr. Parakam Jasin is also raising his hand.
Just to add a comment, it's not a very popular opinion I'm talking about.
Yeah.
So far, the way authorities are looking at this is entirely lopsided. So they are not looking at the national interest at all. All kinds of hair-splitting arguments about it, which are totally irrelevant.
Yes.
And also, unfortunately, we don't have anybody above them to look at the national importance of these things. You know, we were hoping that SCA would get enough teeth to do this, but that is not so, unfortunately. But I will only hope now is that with the restructuring of the CEB, then at least there'll be somebody with some sense to look at it. The recent tariff that were announced is a complete disaster. People who would have no clue at about how business is run come up with totally unacceptable terms. More than the number, the terms. So until that changes, we'll have to jog along, Palpala, to do the best we can. You see.
Yes. Correct, Mr. Arakam.
Mr. Shave.
Yeah, thank you very much. I think I must congratulate SLEMA for initiating this all popular energy management forums. I'm sorry I could not join the first part when you were speaking. So I'm looking forward to the recording to get a feeling of what you conveyed. I'm extremely happy to have been at least been able to be there for the Q&A. And you raised a very valid point, a very sensitive point. The point that seems to be impossible But in my own mind is the way that we approach the problem. The moment you start with you against I against CB, CB against you, CB and SCA is against each other, this will not work.
Yes.
Harsha understood very well and he hinted at that. Without starting a blame game, as Parakrama said, these are national assets that belong to the nation, and we must optimize all the possible renewable sources. I'm extremely happy. I was one of the first to introduce small hydros into the grid, or the first person to go and connect the first power plant. Maybe even Harsh may not know, Italia 60 kilowatts to the grid. So I'm extremely happy on the progress made by the SHP developers. I'm extremely happy, more than happy. And you were talking about the estate hydros. I did not know that they are being gradually being abandoned. In fact, the whole initiative started in 1998 by starting to revive the abandoned mini hydros. And they were coming on stream fairly regularly, fairly well, and with repower and much better layouts and everything. Civil structures were used as much as possible, and then to be refurbished, they were used. And I'm so happy that there are a lot of entrepreneurs gone out of the country and bring in at least sharing our expertise. They bring in all the exchanges. I'm not sure. I mean, that's their business. I'm not trying to talk on that. But at least I think it was Chamila who raised this issue about lack of opportunities for the young engineers in Sri Lanka to continue with their vocation. I am looking at even from another committee in the IESL, where there's tremendous amount of layoffs of the young engineers these days due to the economic crisis, and they should be given an opportunity to go abroad for at least develop as entrepreneurs. So I'm extremely a lot of good ideas for exchange. Now back to the problem that someone raised, and I think it was Parag chipped in, but someone else was saying something. Yeah, and I think let's stop bickering. Let's start working together, and SCA has to play a pivotal role. Harsha is there, and a few others are there who can champion the cause, and they must go more proactively, focused, and as you know, I did Apakutpani against all odds. You name it, I had it. If I could do Apakutpani, I don't see why anyone else can't overcome all the barriers. It's the will and the wish and the determination and the togetherness. Let's work as Sri Lankans for the national cause. And some may win, some may lose. Don't bicker. Go with one focus of maximizing the renewables for the benefit of the country. Right? Yes. I mean, I'm sure whoever the authorities are, don't talk of authorities. You are the authority, we are the authority. I mean, who else is there other than us to be the authority? Don't talk of authorities versus us, we versus authorities. I mean, there's nothing that you, authorities can be, they are all engineers most of the time, right? So you can convince them. If you go with rational arguments, you can convince them. And get this doubt and the, the suspicion out of the way. Get the suspicion out of the way. And as someone was talking about even the irrigation drops, there was this Karyasan study, I think I'm sure Harsha has it, during the master plan study, right? And most of those sites were used from the master plan. So there are if I remember, 208 sites were identified on irrigation drops. Some may not be feasible at all. Fine. But someone was talking about India, but you cannot compare with India. I have been to India, I have been to China. the river beds are miles apart, right? We are talking of a few hundred meters at most, right? So, of course, I have seen in China, sometimes you have these bridges where they have some sort of drop, one side, and the other side. And they have used even the bridges, underneath the bridges, you have these 1 meter, 2 meter turbines. And of course, they can have hundreds within a span of a bridge, So we don't have the luxury, of course. But at one point, we may have to get every drop of energy to our benefit, right? And also, when I joined in, you were just talking about, talking about the solar highway sort of things, right? Why not someone pick up? There was only one Soma Ratna who was my teacher at Trinity long years ago, who keeps on talking about highway solarization. I mean, see the beauty of solarization of the highways, right? Because the load factor, the capacity factor will be, firm, and the distribution of the power will be much more conducive to the CB grid, right? Instead of injecting high variable source in one point, instead of 100 megawatts injection in one point, you divide if you spread out by few hundred kilometers. I mean, that's the wonderful win-win situation. There are win-win situations. Low-hanging fruits are still there. So let's talk of those feasible and doable projects and take it to the end. Be committed, right? Even the developer side as well as the CB side should be more flexible to accept all these. I mean, I don't think they are infeasible. I just saw a nice small video done. Why people are shouting about the solar? Why can't you connect up to the local grids? And all the engineers know why we can't. The laymen don't understand these things. But as developers, we must join hands with the CB, understand their problems. If you can bring capital, bring the capital, even to upgrade the transformers, and do it in a technically and economically feasible manner for both parties, right? Then the national interest will be met. I'm happy that Harsha, in the past, as in his own characteristic way, instead of fighting. That's all he said. I expanded it. Sorry to have taken a lot of your time. Thank you for the opportunity given to me. Can you mute me, please?
Thank you, Mr. Ravi.
Thank you, Mr. Shavi, for sharing interesting comments. Any more questions? We'll be concluding the presentation. Yeah, thank you very much, Mr. Valpola, for the wonderful presentation. Really appreciate. I remember we did the same under finally a project at the University of Moratuwa. Yeah, thank you very much.
Thank you, Rasika.
Timely topic, actually. I
Thank
think,
you,
as you said, we have a lot of opportunities in the mini hydro sector that find all possible ways and means to harness with minimum disturbance environment. Thank you, Valpal, again for your wonderful presentation, and
welcome.
Yeah, and also my sincere thanks to all the participants for their presence. Without you, this won't be success. And then we'll be meeting up again in the this kind of similar energy management forum shortly under different subject. Thank you very much to all of you. Good night.